Okay, in today's class we will discuss vectors. So when we are dealing with motion in two dimensions, motion in two dimensions, we need to specify position. So for this we use vectors. Okay, so to specify the position we need to use a Cartesian coordinate, a Cartesian coordinate system. So we all know the Cartesian coordinate system. It is basically x and the y axis. So this is my x axis and this is my y axis, right? So let us suppose there is a particle which is moving in an xy direction here, and which is here somewhere. Let us denote with p its position, and the coordinates will be x and y, right? That means there is a particle in x and y systems. We are talking about only two dimensions now. We are not talking about three dimensions. Okay, so that's why I have specified x and y axis. If I will speak about the three dimension, then I will need to have the z axis as well, right? So this is a point p, and we can say, sorry, so we can say it's a distance it is making. I can just make this line here and this line here. Okay, so this is origin here, and from the origin this particle has a position x and y with a distance r. Okay, so it's a distance r here. So if it is a distance, then if we say at here, so what will be what I can say, it is y and this is x, right? Now we all know the sine, cos and tan formulas. There is a way to remember them. P B P. So this is for sine, this is for cos, and this is for tan. So if I need to write the formula of sine theta, so I will write from here. It will be P by H, right? If I need to write the formula of cos theta, I will write B by H. So this is for cos theta, B by H, right? So if I need to write the formula for tan theta, I will write from here. I'll write from here. It will be P upon B. So what is this PH and BH? You all have studied that in mathematics. P is perpendicular, B is base, and H is hypotenuse. So the way we remember is, so these are our Hindi words. I don't know in what ways you remember. So it is Pandit Batri Prasad Har Har Bhole. So this P is P here, this B, this P, H, H and B. So this is the way we remember this formula, right? So these are the formulas you need to remember. So now just come back to this figure now. If it's this particle is making an angle theta here with the x-axis. So can I find out sine theta from this? What will be my sine theta? Sine theta is perpendicular upon hypotenuse. Now can you see what is perpendicular here? Perpendicular is y and hypotenuse is r. So sine theta will be r upon y. Okay. Now what will be cos theta? Base upon hypotenuse. This is my cos theta. So what is base is x and hypotenuse is r. So base is x and hypotenuse is r. Now what is my tan theta? Equals to perpendicular upon base. Perpendicular is y and base is x. So it will be y upon x. So these are some of the formulas, and from these formulas can I write x equals to r cos theta from this formula, okay, and y equals to r sine theta from this formula, and tan theta we already deduced equals to y upon x, right? So these are the formulas, and if I need to represent r, then what it will be? R equals to under root x square plus y square. Why? Because we know, according to the Pythagoras theorem, hypotenuse square equals to perpendicular square plus base square. So from this figure, what is the perpendicular? The perpendicular is y and the base is x. So can I write h square equals to y square plus x square, and what is hypotenuse is basically r. So I can write r square equals to y square plus x square, and r equals to under root x square plus y square. So I'm just rewriting it. R square equals to y square plus x square, and I can write this like this. Okay. So these are some of the formulas we have find out from this expression. So can I write it like this? I'm just blocking them so that you remember these formulas. So these are the formulas you need to remember. Okay. Now next is a scalar and a vector quantity. So because we are studying the vector, so we need to know what is a scalar quantity. A scalar quantity is any quantity specified by a single number, specified by a single number and a unit. It has no direction. So if we are speaking about scalar quantity, then there is no direction. It has only magnitude. Okay, a scalar quantity has magnitude, but it doesn't have any direction. Okay, examples of a scalar quantity are, so distance. See, we have already discussed about the distance and the displacement. So distance is the total distance covered. It has no direction. We can go in anywhere. But displacement, it has a specified direction. Temperature, mass, energy, potential, etc. So these are some of the examples of scalar quantity. Now we will speak about the vector. So what is vector quantity? So vector quantity, if we speak about the vector quantity, that means a quantity having a magnitude and direction. Okay, so this is known as vector quantity, which has the magnitude and a direction, right? And it is denoted by, suppose A, and this is a vector sign here. So this and this vector sign, if I speak about this vector sign, so this is known as, this area is known as head and this area is known as tail, right? This is the way we represent vector. So it is, suppose we say it is a vector, that means it is showing a magnitude and direction. If there is this vector sign in top of anything, that means there is a direction. You understand this? Now if I say A, then we can say it is a magnitude. Okay, so this is basically the vector is represented. So this is vector. Now we will study about the properties of vector. So that's the next heading, properties of a vector. Okay. So when we will speak about the properties of the vector, the first property is equality of vectors. Equality of vectors. Okay. So for explaining this property, two vectors A and B are equal if they have the same magnitude and the direction. Okay. That is, I can write here, two vectors A and B are equal if they have the same magnitude and direction. That is, I can write A equals to B, that means magnitude is same and direction of A vector equals to direction of B vector. So if these properties are there, that means the vectors are equal. Now the second property. The second property is adding vectors. Adding vectors. How do we add two vectors? The first is equality of vectors and the second is adding vectors. So consider two vectors. There is a vector A, this is a vector A, and consider another vector, this is a vector B. Okay, now suppose we need to add these two vectors. So what will happen? How do we add? So we basically put the tail of another vector in. See, if we need to add these two vectors, so it will be, my A vector will be this one and B vector will be this one. So what I am doing is, I am putting a tail of my second vector in front of the head of the first vector, right? So when I am doing this and I need to add, then the resultant vector will be like this. So this will be my resultant vector. So when I am making the resultant vector will be the tail of the first vector. So start the resultant vector will will have the tail on the tail of the first vector, right? So this is basically, I can say r dash equals to a plus b dash. Okay, and if it is showing the negative of a vector, that means if it is showing a vector plus minus a vector, that means equals to 0. What does this minus sign signifies? Minus signifies that the direction of the vector is reversed, that the direction of the vector is reversed. So this is how the minus sign signifies. Now my third property, okay, so my third property is, this is first, second, yeah. So if I will speak about the third property now, so third is subtracting vectors. How do we subtract vectors? So consider a minus b, consider a vector minus b vector. That means I can write this a vector plus minus b vector. That means reversing the direction of b vector, right? So this is how we, so if we need to draw this diagram, so a vector will be like this, the same like this, but now we are reversing the direction. So we are reversing the direction of b vector. So it will be a vector and this is b vector. And now we need to do the resultant, and we can easily make the resultant. Okay. Next property is scalar multiplication of vector. Scalar multiplication of vectors. So if a vector is given, if a vector is given a vector like this, and a scalar number is given like m, we can denote it with anything, m, x, y, z, anything, then m a vector is a vector whose which is scaled by the number m, but whose direction remains the same as a vector, right? So this is the scalar multiplication of the vectors. Now components of a vector and a unit vectors. Please write the next heading, very very important. Components of a vector and unit vectors. Okay. So before explaining this, I would like to make a rectangular coordinate system which will represent x and y axis, right? So I will explain it with the help of that x and y system. So this is my x-axis, this is my y-axis. Okay, so this is my x-axis here and this is my y-axis here, right? And I can say there is a vector, consider a vector a. So I'm showing a vector a here. Okay, so this is a vector a. Okay, And so if it is a vector A, then what will happen? What is this? So this will be A y here, right? And what will be this space? This will be A x, right? Which has some direction. So this will be my AX, and we have studied before also. Suppose this is making an angle theta with the x-axis, right? So I can just say it is a components of a vector. Components of a vector. So we have studied in the first topic when I started the chapter. So what will happen? A vector can be expressed as A vector can be expressed as A vector equals to AX plus AY. Okay, where AX is the projection, where AX is the projection of a vector along which axis? X-axis, right? And what will be AY? AY equals to the projection of a vector along y-axis. Okay. Now, if we need to calculate the magnitudes of AX and AY, how do we calculate? I told you the formula of how do we calculate the formula of cos theta and sin theta. So from this figure, we know what is cos theta. Cos theta from this here. I've explained you from these formulas. Where are those formulas? Cos theta and sin theta. The first one, yes, from these formulas. Cos theta equals to base upon hypotenuse and sin theta equals to perpendicular upon hypotenuse. So if I will use these formula here, so cos theta equals to base upon hypotenuse. That means what is my base here? So base is AX, and what is my hypotenuse here is A, right? So this is cos theta. Okay, so and what will be my sin theta? Sin theta equals to perpendicular upon hypotenuse. So what is my perpendicular? AY, and hypotenuse is equal to A. So from this equation, can I write AX equals to A cos theta and AY equals to A sin theta, right? So can I write it like here A, so can I write AX equals to A cos theta and AY equals to A sin theta? Let us check. Yes, A cos theta and AY equals to A sin theta. So these are basically the magnitudes of A vector and Y vector, right? And we already find out A equals to, we know that hypotenuse is A square, hypotenuse square equals to perpendicular square plus base square. So what is my perpendicular? AX square. And what is my base? What is my perpendicular? AY square, and base is, okay, so perpendicular is AY square and base is AX square. So can I write A equals to AX square plus AY square? Just remove this, because we know the formula is H square equals to perpendicular square plus base square according to Pythagoras theorem. Okay, so this is basically is the value of Okay, so next and the last heading for today's lecture is the unit vectors. Okay, so for calculating the unit vectors, we are talking about the 2D here. So 2D and 3D. So when I'm talking about the 2D, then there will be, I will include I and J, and for 3D it is I, J and K. So I in X direction, I in X direction, J in Y direction. Okay, so if I'm talking about I, J and K, so I X direction, J Y direction and K is Z direction. Okay, so I, J, K in 3D motion and I and J in 2D motion. So, so unit vector is denoted with the help of a cap like this. This is basically a unit vector. Okay. So if I am saying I vector is a unit vector along x axis and J is the unit vector along y axis. And if I'm speaking about the 3 dimensions, then K is the unit vector along z axis. Okay, so I, J, K are the unit vectors. So what can I explain in unit vectors are basically we can just if we need to show it on the graph, then how we will show? This is my y axis, this is my x axis, x and the y axis here, and if I need to show the unit vector, then this is basically I and this is basically here is j vector. So unit vector means equals to 1. So I unit vector equals to 1, j unit vector equals to 1 and k unit vector equals to 1. So these are the unit vectors where dot represents the magnitude of the vector. Okay. So if I need to represent A now, let's get back to the Cartesian system. If I need to represent a vector in 2D, then in terms of unit vector, how can I represent? I can represent ax, magnitude of A, unit vector I, plus magnitude of A, unit vector J, like this. Okay. So ax and ay can be positive and negative. So this is the way we represent a vector in terms of unit vector. I can write here a vector in terms of unit vectors. Okay. Now if there we need to represent the r, the position of the vector, right? So how we denote the position of the vectors? Look again, this is my y-axis, this is my x-axis, x-axis, y-axis. It's the same thing we have I have explained you previously also. There is a particle which is moving in an x and y Cartesian system. So this is my position vector r. Okay, and this is x and the y-axis, and this is in y direction and this is in x direction. So if I need to represent r vector, so r vector is basically a spatial vector, that means the position vector. So how can I represent x? Because x and the unit vector is I, and y the unit vector is j. Okay, So from this figure, if I want to denote the r, then we can say x and with the unit vector I and y with the unit vector j, right? If I need to, let, now how do we solve? So let a vector equals to axi plus ayj and b vector equals to, I can say, bx unit vector I and by unit vector j. If I need to add both of the vectors, so I can say the resultant vector is r vector and I can say it is a vector plus b vector, right? So how do we add them? I can easily write a x I unit vector plus a y j unit vector plus, now put the values of b vector here, b x I unit vector plus b y I b y j unit vector, right? Now take I common, so it will be ax plus bx I unit vector plus ay plus by j unit vector, right? We can write it like this. That is, you can simply add their components. So if I talk about the magnitude, so can I write it rx equals to ax plus bx and ry equals to ay plus by. So I'm just talking about this term. So this is x and this is y. So this is rx and this is ry, right? Now I can easily write r resultant. So I can write rx I plus ry j, right? So r resultant, how do we find? R equals to under root rx square plus ry square, right? Or we can say that r equals to, I will just put the values of these ones what we have already find out on the top. So rx equals to ax plus bx. So can I write ax plus bx whole square plus ay plus by whole square. So this is my magnitude of r. Okay, so we will do the numericals based on this topic, but this is basically the theory for the topic vectors. So it will be more clear when we will do the numericals based on this topic.